My name is Beau Vrolyk, and I'll be your commentator, narrator, I don't know, corral cowboy, keeping everybody in line. Stan, you want to say something to introduce yourself? Everybody knows who Stan Honey is, I think. So, yeah.
I'm Stan Honey on the board of USALA. My second career was as a professional navigator, and then I've done some projects that overlap those.
Yeah, so next is Lynn Lynch from New York Capital.
Hi, I'm Lynn Lynch, Selling Northrop for New York Capital, over Post as well, and International Business Officer.
Yeah, and Tom.
Tom Duggan, Financial Race Officer, Chairman of the Racing Management Committee at the USALA.
And Alec.
I'm Alec Stewart, the founder and CEO of Velocitek and electronic instruments for racing sailboats.
Initially, I want to just say that the idea here is for this to be participatory. I mean, we want to learn from you just like we're trying to tell you about some other stuff. So please don't be shy. Stan?
So I've been asked to just give a little bit of background on the technology that we're talking about, which is the use of GPS and specifically RTK GPS in support of sports. And so that's the answer to the question. What do NASCAR, the America's Cup, SailGP all have in common beyond turning left? This is 2000. This is a system that I led the development of in my company that's called SportVision. SportVision is the company that did the yellow line in football and the K-zone in baseball, and you'll kill me for it, but we also did the hockey puck that gets tracked around. But this is a system that we introduced in the year 2000. We used RTK GPS, and to just give a quick preview, GPS, as you all know, nowadays the modern version is L1, L5. It works to about a meter, sometimes a little better. But then RTK GPS, it actually tracks the carrier phase of the signal from the satellites. And so it works much, much more accurately. It works to 2.5 centimeters, which is an inch. And it's more difficult to do. The receiver is more difficult, and the whole system is more difficult, but it is doable. And so in 2000, we built a successful RTK GPS system that worked in NASCAR. We introduced it in 2000. It's been used in every single NASCAR race since. It's now in its third version of hardware, but the upper right is the first version of hardware. It was tens of thousands of dollars per car. The battery pack was as big as the unit you see. You can see the cooling vent. But the interesting thing was that it absolutely stunned the government and the military to discover that 2-centimeter GPS, which is something that they had hoped you could only do with P code for military purpose, that we were able to find a way to do it without the military decryption codes, and not only do it as surveyors do it, but we were able to do it on race cars that were going 200 miles an hour with ignition systems in every car and an overhanging chain link fence that covers half the sky. So you could only see half the sky at a time, and the part of the sky you could see would change once a minute as the cars rip around turning left, as they do in NASCAR. And then you see the principal effect on the left, those pointers, showing who's who. But then it also, computed the speed and accelerations and all the other things associated with NASCAR. And then NASCAR increasingly over the years used it officially. So they used it as part of their rules enforcement and accident investigations, etc. The thing in the upper right that's got a Honeywell ring laser gyro, as well as a Novatel RTK receiver with very special firmware. This is a descendant of the same system. I was asked by Ellison and Russell Coots to do a system for the America's Cup in 2013. We started this development in about 2010, and this was the system that did the live line. So you all remember the graphics that are on the water for the America's Cup, and this is the same system that's still in use in SailGP. And the Pelican case on the right is the RTK GPS system. The Pelican case on the left is the battery pack. It was about $150,000 worth of kit on each boat. It worked perfectly, meaning the boats, we were able to track them to 2.5 centimeters and track their headings to 1/10 of a degree. It was the principal investment was made because they wanted to do the live line graphics overlaid on the TV, which you've all seen. But then immediately, the race officials and umpires wanted to use it, and so they ended up doing electronic umpiring, so that all of the factual decisions, the computer was able to provide the umpires with those facts, meaning was there an overlap at zone entry? And the system, of course, called OCS. And it worked perfectly. And compared to NASCAR, where you have 200-mile-an-hour cars with chain link fences and ignition systems in every car, sailing is a cakewalk because you're out in the open, you can see most of the sky. The sailboats tend to be electrically quiet, so the sailing was quite a bit easier. So that's the history of it. But the interesting thing that came out of both NASCAR and the America's Cup was that we absolutely had to have that 2.5 centimeter accuracy. And then all of the race committee, the officials, the umpires, and I think some of you probably umpired in the America's Cup, absolutely grew to depend on that accuracy. And there were some legendary events that happened during the Cup where there was a situation where the crew said that there hadn't been contact. And we said, well, actually, look on your starboard bow, 12 feet aft of the bow, and there was a scratch. And the crew was just stunned. How could we do that? Well, the answer was, we knew where the boats were within 2.5 centimeters. We knew their heading to 1/10 of a degree, and we could see the rate of change of the heading. So when one bow gets close to the others and then suddenly you see its rate of turn change, well, only one thing could have happened. The bow slid against the other boat. So the accuracy was 100% dependable, and it turned out to be essential for sailing at that level. This is some of the other kit that was used in the America's Cup. They asked us to also put in sort of a crew communication system. That's the upper left, where you can see that the sailors on the boat can decide whether to hoist a Y flag or a B flag. And then the race committee can send information to each boat saying whether they've received a penalty or what the time of the next start is. The colored lights on the upper right that other boats can see that show whether a boat has protested, whether a boat has been penalized, whether a boat is within the zone around a mark, whether a boat is within a certain distance of the boundary along the outside. And then the same lights are visible to the crew in the lower left. Those are lights on the crossbeams that the crew could easily see. And then in the right is one of the mechanical drawings of the system, but the GPS antenna is on that little pie pan that's aft of the camera mount behind the center beam. That concludes my comments, Beau.
Thanks, Stan. As an engineer, following Stan in a presentation like this is an honor, but it's also a challenge. I have to stand up here and remember what I'm supposed to say while still struggling with an overwhelming sense of inadequacy. So as I mentioned earlier, I'm the founder and CEO of Velocitek. We're a small business based in the San Francisco Bay Area that manufactures electronic instruments. This is our most well-known product, the ProStart. The ProStart was actually used alongside Stan's liveline system on the AC-45s. You can see the ProStarts there, but it was not connected to the big boy GPS at the back of the boat. Our real work with automated starting systems really began at the end of 2022 when the New York Yacht Club race committee got in touch and asked us if we could develop a system for their IC-37 fleet. Here's a beautiful IC-37 start on Narragansett Bay. With IC-37s, there's a limit of 1 pro sailor per boat. So the platonic ideal of an IC-37 crew is a Cat 1 with a flexible work schedule who's hopefully been to the Olympics at least once. The New York Yacht Club Race Committee is made up of really dedicated and knowledgeable volunteers, and they work with some of the best race management professionals on the planet, like Lynn Lynch and Tom Duggan, who are very lucky to have on our panel today. The New York Yacht Club is a little bit unusual in that they don't really have a shortage of race committee volunteers. So they're not necessarily looking for a labor-saving device. Their overriding concern is to run lots of fair races and make accurate line calls. Here's an overview of how automated race management systems work. You have a GPS sensor on the pin on the signal boat, and you have GPS sensors on all the boats, and all these components can talk to each other using a wireless network. So when a boat's maneuvering in the pre-start, it's getting a constant real-time feed of where the pin is and where the boat is. And then the boat also knows its own location because it has a GPS sensor. And so with these inputs, the boat's own location and the location of the ends of the line, you can calculate the distance between the boat and the start line and figure out if the boat's over the line or not. And then someone on the signal boat has a mobile app that they're running on a phone or a tablet that looks something like this. It tells them the status of all the boats and lets them initiate a start sequence. Have you guys heard of the Pareto principle or the 80-20 rule, where 80% of the results come from 20% of the efforts? Well, this of the thousands of hours it took to develop this system, this humble blue screen on the right that shows how long the start line is and the wind angle it's square to is probably, it took about 20 minutes to code, but it's 80% responsible for Tom's willingness to be on our panel today. So it's super convenient if you can have an automated system like this determine who's over and who's not without any human intervention. This lets sailors know instantly and unambiguously if they need to go back. And it also frees up mental bandwidth for the PRO to worry about higher level race management tasks. The problem is that some people, like Lynn and Tom here, will stand in the way of progress, even if the self-driving car only occasionally runs over a child. To make people like this happy, the threshold the system needs to meet to fully automatically make OCS calls is it can never make a call that's obviously wrong to a professional sighting the line from the signal boat, or for that matter, some Olympian who just started next to a line end and knows where their boat is better than I know where my own hands are. So here's some error bars showing plus minus 1 meter, which is the best you can get with non-RTK GPS, and then plus minus 2 centimeters for RTK GPS. And the beacons on the ends of the start line suffer from similar errors. And if you're unlucky, you can have a boat next to a mark, and they can have errors in opposite directions. Most of the time, this doesn't happen, but if you run enough starts with enough boats, eventually little Timmy's luck runs out and the robo-taxi runs him over. The first event where we fielded a full RTK system was the Resolute Cup last September. This was the first event outside of the America's Cup or Sail GP to use RTK race management. Helped the race committee run more races, and it also helped make the races more competitive. You can see in the photo here, you could almost run a ruler across the bows, and this was pretty typical for the whole event. When the start's like this, the first windward leg is really tight, and that makes the whole race more competitive. Here's a look at the components we had on each boat for the Resolute Cup. So there's an RTK GPS receiver, cell phone in a waterproof case, and then a mass-mounted display. For this season, we're developing a new product called the RTK Puck that combines the functionality of the phone and the RTK GPS receiver into a single self-contained unit. as time goes on, this stuff just keeps getting smaller and more affordable. Now I'm going to turn it over to Beau Vrolyk, who's very graciously agreed to be our moderator. And a big thank you to all of you and to our panel for being here today.
Thank you, Alec. Well, we've now accomplished one of my 3 goals for this talk, which is you now know what this thing is. The second goal is, why do race officers and sailors actually need this? What's the benefit, and to who gets that benefit? I wanted to kick it off by basically saying, Lynn, you were an incredibly strong advocate for this. I'd like you, if you could, just share what motivated you to step up and insist this happen.
I am an advocate for it. I was initially a block, as Alex said. And I wasn't always the most exciting person to have on the calls because I kept saying, what if? Yeah, but then what? And then what if that happens, right? All the unintended consequences of trying to be better than what the humans are already accomplishing. But I think what helped me turn the corner is when the accuracy and the fairness of the whole system started to become very clear, right? The more racing we could get done, the less issues that were on the course. It just lent to a better experience for everyone out there, as well from the sailors, which is all about, although sometimes it's more about the race officers. But it's amazing for the race officers as well to be able to just kick races off and go and not worry about people coming back and having to redo it. So the ability to create this sort of ultimate fair race course is definitely what kind of turned the corner for me.
Those of you who are race officers know the last thing in the world a competitor wants is to say, oh, geez, the PRO just put up an AP and they're going to move the starting line because the wind shifted 15 degrees. And everybody sits around and then they start howling because they want to get that new position pinged, and in a big fleet, it takes forever. Tom, why don't you give a little chat about those kinds of operational issues that come up for the PRO?
Sure. So that you folks know, I'm not speaking for U.S. Sailing or anybody up here. Speaking for me. I end up at New York Yacht Club because my wife works with Lynn, and she tells me to go there. So a couple of years ago, I started going on the IC-37s when these folks were using the Velocitek, and I call myself the crash test dummy. It became, if Tom can run this, anybody can run this, okay? So my job essentially was to hang, watch, see the display. Like Alex said, I would make comments on the display. It should look this way. It's better if it looked that way because I'm not quick enough to see it this way, and that sort of a thing. One of the initial things, as Beau just said, was no pinging. I don't know if any of you have sat, all of you are coaches and all that sales. You sit on the end of a line and you watch people ping. People suck at pinging, okay? Right. There's already trouble right there. I watch, I think, oh my God, here we go. Here's an OCS right here, okay? So the fact that they don't have to ping the lines is a big bonus. I've spent a couple of years now on the race committee with these folks and watching them develop the RTK. And, in the beginning, we would make the calls ourselves and then compare it to the call that the machine made. And then as we got along, first they put the pin in and the boat in on RTK, and then the boats. And I've been able to witness how amazing the difference is between when I first stepped on the boat with them with the regular, the L5, and the difference that the corrector makes. It's amazing.
Great. So just to follow up on that, you mentioned that the behavior of the sailors changed. Could you give us a couple of examples, like the first time they used it, the second time they used, what was changing in their behavior?
Sure. I mean, as you all know and have worked with these systems before, once they know that you know that there's everything changes, right? Everything changes, right? So you go from maybe you have one jailbreak at the beginning of the event, and after that, that's the end of that, right? So, because you call them, the machine calls them back instantly, and that solves that issue right there. So for race management teams, one other thing that Alex brought up was the setting the line. It's unbelievably easy to set the line, and because I need you to go up 1 degree and down 1 degree. It's so simple, and then with the behavior of the sailors, it changes everything.
So I think the other thing that we got to watch is as the system progressed, as our knowledge of applying the system progressed, the sailors started to trust it. And instead of initially being more like we were, which was hesitant to go down that road and kind of like a why break something that's not broken? Why fix it if it's not broken, right? We've been able to do this. The process continued to get more and more specific and more spot on, then they started to trust it. And they also started to trust Tom on the boat, whoever's on the boat, to not just accept whatever was happening with the machine. We would step in and say, no, that one didn't work. We're going to do it again for whatever reason, right? And that rarely happened, and now it doesn't happen anymore, right? When we got to this next level with the RTK, it's completely trustworthy, which has been phenomenal.
Just one observation as a navigator on maxis about getting rid of the pin parade. When it's windy and you're on a maxi and the race committee correctly moves the pin and now everybody has to reping, it's frightening. That may be the most dangerous thing we do, is having all these maxis careening around trying to reping. And the cost is probably unimaginable in terms of the flogging of the sails. So it really is great to get rid of that ping parade, both for safety and the fact that we can do more sailing and less waiting around for people to ping.
They can't harass us as much as they're not going by the signal boat every time, too.
So, Stan, there was a fairly famous protest between Comanche and Wild Oats in which Wild Oats was on port and tacked right in front of Comanche. And there was a determination that basically the boat behind had not turned until it had to. Can you talk about that and what was on that boat?
Yeah, it was an interesting descendant of the Liveline system. But because I'd just finished the Liveline development, I put on board Comanche it was a fiber optic gyro based inertial navigation system. So we were navigating to RTK accuracy, but we measured the attitude of the boat to 1/100th of a degree in heading, pitch, and roll. So then we had this port starboard in the Sydney Hobart race, and Jimmy Spittle's driving Comanche, and of course there's Rico driving Wild Oats. There was footage on the camera on the helicopter, and then in the protest hearing, it was fascinating. Rico's defense was that we changed course, and so the committee asked me, "So do you have any evidence that you sailed straight?" And I said, "Oh yeah." And so, I showed the plot of the boat and I showed the graph, and they said, "Well," and then Rico said, "Well, the compass might not be right." And I said, "Well, actually, this is accurate to 1/100th of a degree," and demonstrated that. And Rico's final defense was, "Well, that's not what I saw."
So I think we're pounding into the ground with does this work or not to benefit the sailors and the race committee. One of the things that I was struck by when I first bumped into all these efforts was that with whatever the larger variance might be of a not RTK corrected GPS signal, if you want to make it 1 meter, you can say, wow, okay, somebody could be 1 meter over and they were told they were on the line. Or they can be 1 meter below the line and told they're on the line. And so, the first time I've sailed for some pretty good skippers, and I'm thinking of the ringing in my ears where I was trying to help call the line, and somebody like Paul Kayard says, "What the hell? Those guys, they were, 3 feet ahead of us or 2 feet ahead of us, and we got called over and they didn't." And to reflect on something I think Alec said, it's pretty clear that humans will tolerate mistakes made by race officers. I mean, Tom does it all the time. We tolerate Tom, and nobody tolerates it. But what happens is with machinery, like with self-driving cars and running over some kid, nobody tolerates that. And so the standard that the technology is being held to is actually much higher. And what drives that is fairness. We just want to start fair races. And my favorite example is there was a jailbreak that Tom was telling me about, and they called back, what, half the fleet or a third of the fleet? There was someone who won that start. There was some guy right on the line headed for the weather mark, and he got denied the right to actually be ahead of half the fleet because he did it right. And that lack of fairness is what drives me nuts when I was a race officer. And if we can get rid of that stuff, to me, I'm editorializing instead of being a whatever. If we get rid of that, we have a huge win. So one of the other things that I think is important here is to realize you've already seen what's happened to the cost and the size and the complexity of the device as it shrinks. I think we're in for more of that. The tech industry's always done that. So I've got a question based on a response that I got from a big boat sailor when I told him what was coming down the pike. And I said, you're going to get this little display, and it's going to show you distance to the line and time to go, and it's perfect, it's really accurate, it's all super. The guy looked at me and says, you are not putting any more displays on my boat. I refuse. We've got 4 great big ones on the mast. We got them, in the cockpit. It's all over the place. No more displays. Forget it. You make it work with the B&G, or I'm not buying it. So you guys, we're going to end up being able to hook this into the existing networks?
So we're making a version. I actually have a mock-up in my bag here. So a version of this that has a NEMA 2000 connector on the bottom. So it'll connect to the NEMA bus, and you can drive the B&G or Garmin displays with it.
Yeah. Okay. So that's good news. But I found it really interesting that in the past we've always tried to build things which are all of the complete solution. But more and more, there are literally thousands of boats with Raymarine and whatever. Pick a network, and those networks don't particularly work well together. And so it would be great if we can just use the existing stuff. Thank you. Other comments? Okay. Well, yeah.
How much?
Oh, $1,500? Yeah. About $1,500.
For a boat? Yeah. And for the overnight cemetery?
Same deal, same technology, to know where the ends of the line are.
So $1,500 region of the line.
Yep.
But all this depends on the continued availability of that RTK signal. So when the government found out it was available without their decryption, is there concern that that will be degraded or removed, made unavailable at certain time?
No, the government has come to grips with the fact that the use of now GPS and GNSS is so embedded in our society that it's not a reasonable option to deny it. Although the governments do have the ability to do selective denial in certain regions, and that would be the response of to certain kinds of cruise missile attacks or something. But if that turns out to be an issue, well, then we can probably think of something better to do than finishing our sailboat race. But the government is pretty committed to having it be continued availability. And then it turns out also that these systems are working with multiple constellations. So that in addition to the US GPS system, it's working with the GLONASS system, from Russia, and the European system. So.
When I was first educating myself on this stuff, I also realized that Tesla and other car manufacturers are trying to use similar technology to know what lane they're in, so they can actually start moving the car over during self-driving and get off at the right exit. So they're not doing that with 1 meter accuracy. They need to know where they really are. Currently, they have to do that optically by looking at a camera, but that's really tough at night in a rainstorm or when there's snow on the road. Your self-driving car, she said, don't work so good. So other questions from the audience? Yes?
First off, you have to set up the sort of imply it. Sailors know on their display life how far they are from the starting line, right? So that's it. So you're taking away all that. And did you have any debate about, and especially, well, let me primary question, how do you handle that the classes that don't allow electronic devices? Like the deeds and...
So it's pretty easy. So we can show or not show whatever we want. So in the IC37s, they were used to having distance to line. They'd manually ping the line. So we gave them that. But you can run the system very easily where, for example, you could just have the timer, right? The timer's automatically synchronized. So say in lasers, everyone could have the time, but nothing else. And then just a message telling them if they're OCS or not. Or you could even take that away and show the sailors nothing, and only the race committee has the information. It's really flexible in terms of adapting it to whatever a specific class wants.
Yeah, yes, please.
The top lineup starts, does it work the finish? We'll sort out that.
Well, that's a great segue. I was just about to take us to the next question that I went through in my own thinking, which is, so the PRO would probably like to know where the weather mark is, and would like to know when the boat's finished, and also would like to know how far, the judges would love to know how far apart these boats were going around a mark, because when you ask for redress, you say, well, I was right behind the second place boat, and you were actually 4.5 minutes behind.
Yeah, the finish is part of it, but the other thing that turns out to suddenly get more important is to clear a boat. Meaning if you're using the system in a way so the boat knows where they are on the line, the boat's going to know instantly that they're OCS. And the boat, if they have room, they might clear themselves very quickly. And so the system has to also help out with that.
Yeah, we had that happen during the Resolute Cup, and it was funny because, leading up to the Resolute Cup, which was the first time we were deploying the whole system, right? Up until that point, we were beta testing it, but the race officer still made the OCS calls manually. So this would be the first time, and I remember distinctly on a call, Alex said, we really should call them clear. And we all pushed back and said, no. We never call boats clear. Let's not start there, right? We're going to do one step at a time. We'll let them know that they're over. The display will show OCS for, I think we prescribed 2 minutes or 3 minutes, and then it turns off, right? Their job to clear it. And we had this jailbreak, and we thought we did a good job. And at the end of the day, we had like 4 or 5 scoring inquiries from people who were marked OCS because the humans couldn't see them come back, right? They knew way before we did that they were over, dipped the line, and then went back up. So in the subsequent race, when we used it for the last North Americans for IC37, we had the units clearing them as well. So that was kind of an interesting progression of learning the sailing management part of it with this increased. We didn't think about that as a side effect. So now we have it clear as well as call OCS.
And the thing that it does too is it shows distance to the line, and it'll go negative when they're over. So as we're still trying to decide what's going on, people are already turning to come back. So we had, in the last IC37 event, we had, 11 or 12 out of the 21 or 2 boats, whatever it was, over. And I saw boats starting to clear, as the start went. So it was pretty interesting to watch. So they got an enormous amount of boats were over, and they cleared in, geez, I don't know. They were all clear in like a minute. I mean, it went so fast, I couldn't believe it. So,
you have to tell them what.
It sounds like you said a shitty line.
you think it's easy being me? It's not. It's not. I'm just saying, right? I said a perfect line.
Okay, yes, in the back there.
This looks like it's set up for very steady wind. What do you do when you get to inland lakes where the wind can vary 10, 20 degrees and then go back and be 10 or 20 degrees on the other side of the sea? And it happens rapidly.
Well, I don't think this solves that problem. I think it lets the race officers respond more rapidly to to the problem, and to know it's happening. And I think you want to comment on that, Tom?
We wouldn't do anything differently than we would if we weren't using the system. We try and balance the line, and if we had to blow off a starter AP or something because it was loading up at one end to the other, we'd behave the same way. So it's all the same. The only downside of this that I see is if you had you've all seen race committees that have used penalty flags to hide a bad line. Right? In this series, in this sort of a system, you could get a race officer who's lazy and hide a bad line because this thing will call everybody over, right? So that's the only downside of this that I see. So, but a race committee shouldn't behave any differently. They should make sure the line's balanced and everybody's spread along the line. And if it's not, go back and try it again. It just, instead of a general, you might do it with an AP. It doesn't matter, but you'd behave the same way.
Yeah, please, Tom.
One of you talk about what it takes to proliferate across dozens of yacht clubs beyond the regatta. What are the barriers for race committees to learn the implements and for police to take in?
Yeah, our goal here is to make something that's like a consumer grade product that like our Pro Start that I showed at the beginning is like really famous for people can use it without reading a manual, and that's our goal for this system is that we want somebody who's not excited about technology for the sake of technology, but who just wants to run a race to be able to order this hardware on our website and figure it out quickly. So I think it's really a product design, or I see it as a product design challenge, how to make something that is easy enough to use, that it doesn't require on-site technical support. I think that's the real key to having it proliferate is for it to be easy enough to use that anyone can just buy the hardware and use it.
Yeah, one other observation is if you put yourself, viewing our sport, multiple years into the future, the one thing that's unimaginable is that, race committees having to look at multiple screens because different parts of the fleet are using different systems, or race committees having to hang, 3 or 4 different trackers in the pin because different boats have different kinds of systems. And in fact, we have one of, Vacros, one of the competitors to Velocitek, right here with us in the room. But I guess I just, urge all of these companies together that our economy benefits from having multiple different car makers, but we all benefit from being able to use the same damn roads. So please, work together and find standards so that in the future, race committees, like St. Francis in New York leading the charge, can pick a system, but that the electronics on the boats, can work together so that we don't have an unimaginably ugly future where boats are having to have multiple systems and race committees are looking at multiple screens and we have a bunch of crap hung off the pin. Please don't take us down that road.
I think it's clear at this point to be able to implement beyond the U.S. doing, which is great. Thank you for doing what you're doing. It's try to get a fleet and find a fleet that's willing to buy in. So everybody's probably got some fleet that will be better at buying into this system, whatever system it may be, than other fleets. And inevitably, you're going to set yourself up for running races where, say, maybe it's JR5 you're using this system, and then the next start 5 minutes later not using this system because they haven't been able to implement it within their class. And furthermore, perhaps some smaller classes might be able to get involved with some sort of a subsidy program where maybe the OA wants to take the tiniest class and own 5 of these things for that class only and be able to get it out to smaller classes that wouldn't necessarily be able to afford it en masse, but to be able to test it with that small class. So I think those in the middle are going to have a problem. The big classes, probably they're going to get behind things and they're going to thrive the knowledge of this and then talk about it at the bar and how great it is. And then perhaps maybe we as OAs can help with some small implementation at the very bottom of the class sizes where we can really show those groups as well. So that's what we're trying to think about at San Francisco Airport, how much we can invest. And we certainly can't invest in buying 35 of these things, right? But we probably can buy 5 and be able to show some people and some classes what might happen. So that's our plan, but you was really relying on some bigger fleets to be able to say, look, we're all going to spend the money at the same time and be able to go do it. But BOA has to be one step ahead to be ready when you turn it on.
Yeah, it's a great point because right now,
New York, St. Francis, and San Francisco all have fleets that are owned by the clubs, and I'm sure there are many, many others. And so, for going to something like St. Francis Sailing Foundation and saying we can make racing much better for our J22 fleet if we just give us the money, basically. And I think they would be very receptive to that. And I think the same is true of San Francisco Yacht Club. And it would be an excellent way to get this kick started. The other issue is, I think at the top end of the sport, we're talking just feeding my crew dinner during Big Boat Series was more expensive than one of these things. And I've got a big old wooden boat with a lot of bodies and hungry mouths to feed, but on the grand scale of driving a sailboat that's 40 feet and above, $1,500 sounds like a lot of money, but it really isn't. And I am well aware that many people feel like this kind of thing might be kind of a tax, but I think you just have to watch what happens. Yeah, please.
So talk a little bit about strategy to raise a business question for Velocitek or others about getting this down as it needs. Because, if you don't already have the Velocitek at $1,500 is a lot to ask a laser sailor when they're banned anyway. So you got, and then you've got to staff 100, 200 boats, forwards, So talk a bit about the strategies for taking this technology to Z.
So if you make it not be RTK product, it's the errors get to be about this big, but you can make it way cheaper. So this, like the RTK puck, if it didn't have the RTK GPS module in it, would cost about $300. So that's probably the ticket for youth sailing, and people are really price conscious.
Yeah, please. Yeah. I would disagree with you on that because if you go to a meter's for a problem, it's a third of the length of the boat. And you're essentially going to potentially have, those errors compounding, and it's not going to work well. So the real issue for these is making sure that these things can last for all day long for them on one charge. The second thing is, if we're going to ask us to buy them for these boats, for a sailor to buy for the boat, it has to be worked with every single race speed that they go to sea. And so I think we go back to Stan's point, which is that regardless of which system a particular yacht club or race manager chooses to implement for their racing area, we need to be able to buy one of these things once for our boat and know that we'll work with anyone that we go to work with. And until we know that that's in fact the case, do not be able to get this to be proliferated outside of a closed system for a particular yard.
Yeah, definitely.
Could I follow on to that? Are these systems transferable to other boats?
Yes.
Tell me a little bit about that.
You just unplug it, unscrew it from the wall, screw it down.
So you could go from an OpD to a laser to a J70.
Yeah. So the way our system worked last summer, we used it on sonars and IC37s, and the central app on the signal boat that's controlling everything. They just have a drop-down menu and they choose which boat it's on, and then that updates the device's model of where the perimeter of the hull is.
But that means that you have to know where someone's putting the device on the boat, or does it have to be in the same place on every boat?
It definitely has to be in the same place on every boat.
That means you have to have had some sort of study done that says that if you're picking this boat, it's going to be in this location, and everybody knows. So that has to be proliferated out for the J22, the Belgius 24, the J24, the Snipe, the Laser. All of those you have to figure out where the right place is and make sure the classes are willing to have something so in that location.
That's correct.
Yep.
And therefore, then it is a race, if you put it in your race documents as well, right? This is where we mounted, by these specs. It can't be turned one way or the other, right? That's the design features, the fit on it. So by optically, you can see if it's mounted correctly, right? If it was just all smooth, you could tell if it was oriented the right way.
Yeah, this guy's been trying for a while.
Yes. Hi, Jake Kahn, Ricaros. So we've run about 300 vets in Fisher Flag, different classes, all the way down to the Opti and, out in big boats, like. And the question you asked is a really pertinent one, but the challenges that come, just the logistical challenges of getting devices on those is often actually far further the technology career. We send all this outboard technology, and then we have to hand the sailor advice and the Velcro and mass. And so that's like, those two things have to come together. And so I think part of the equation that we found is sailorification is really critical. So you have to work with the race organizers and the sailors well in advance. People understand and expect what's going to happen if it's something new. And then the other piece of it, I think, is that sailors getting used to this over time really makes a good difference. So I think working with Fluffs, we found that model of you're buying that fleet who's going to pioneer this Kermit flow, and then it can spread out. It's worked really well. But I think something we don't, kind of take away as a question back to our own clubs and race activities is who in that group is interested in taking this on? How do we get this started in Give area is something that, it's really important. It's a big area.
Yeah, Sean.
Yeah, we do a lot of small boat stuff, and as a parent, I mean, I've made $1,000 to be able to see his kid's boat and my boat on a screen, and I would love if you could look at that selling point. I can't get out on the water to watch the race, but I can watch my kid and where he is on the race course right now. And if you say it like that, then I put one of my myself though.
Well, yeah, and we run an Opti regatta at St. Francis called the Opti Heavy Weather, and knowing where every one of those kids are on the city front, because they got to sail in an ebb tide because they can't get to the weather mark in a flood. So they're out there in 25 plus in an Opti, and you really want to know where they all are.
Well, it's not that I'm worried about their safety. I just want to see how they're doing because I don't get out on coach foot.
You don't care about their seat.
Sean, that was a slow pitch. That was a real slow pitch.
So one thing I forgot to mention is that for the Resolute Cup and the IC37 North Americans, when we were doing the full RTK stuff, we also had a live feed on the internet of all the racing, so you could see where everyone was. And we were just sort of using that for entertainment, but it's, I think, really cool for safety with kids. And then also because that track has a full RTK accuracy, it's a very accurate reference of what happened. So I could see in the future where that really forestalls a lot of protests because everyone can have the same ground truth.
And coaching, yeah. And Bruce, yeah.
Yeah. What do you use for your reference when you dry your boat? Do you use the line dries for manufacturer or what?
Yes.
And also, like every other fleet in the world with some piece of equipment that's supposed to work in a certain way, the measure is going to need a tape measure to make sure that somebody isn't cheating by moving the puck around.
Yeah, the only reason I ask is because I've owned J boats and bar boats, and the dimensions on the beam are more than an inch different from boat to boat. So how do you clear that boat that's skimmed down and they're being tested? Where's just or Como?
Yeah, well, all those boats with all those different dimensions also all have the one design handicap in most cases. I mean, it's the same problem, right? The boats aren't all the same size or weight or whatever. But the best we can do is the best we can do.
How does this function in venues without reliable cell coverage?
So the system we fielded last summer does not, and the RTK puck.
How does this function in venues without reliable cell coverage? Like my own club, there's no cell where we race.
Yeah, the system we used last summer used the cell network. The thing coming this season, RTK puck does not use the cell network, so it's not really dependent on that.
Yep. Back in the.
American Yacht Club, we have a few mark set bots that we've been using for some of our bigger events. I was wondering, do those technologies work together at all? Do they communicate? And if not, are there any struggles with race officers having to use multiple different kind of templates for GPSs and marks and posts?
Yeah, this is a great question because the last thing we want to do is have, like Stan says, two screens, one that shows you where the mark bots are and the other one that shows you, your boats and starting line and everything else. That's exactly one of the reasons we would like Vakros and Velocitek working together with people like the mark bots, and they're probably not the only mark bot around. So it's a classic example of, I'm from the tech industry. The innovators always get out ahead of standardization. They always get the job done so it'll work, so the customers demonstrate they like it, and then they all arm wrestle about certain interfaces. And I think we're entering the arm wrestling phase with this now. So people are going to say, wait a minute, it has to plug into the B&G or whatever, NEMA bus. It's got to work on some kind of standard power supply, and hopefully those will be similar. It's got to be installable in an easy way, and they all need to work the same way. There's certain things that aren't differentiating. In other words, in fact, it's a big differentiation to a negative if you have an incompatible interface somewhere that nobody else can work with. So, once we all get to the point where we've got products that are shipping, then the real arm wrestling starts over, okay, which standard are we going to do? And I think we're actually in the arm wrestling phase right now, talking about different ways that these various vendors can work together. Because the last thing we need is we don't need a repeat of the PC market. Let's put it that way. A whole bunch of things that don't work. Yeah, in the back. Yeah.
Did you use these pokes on? You said you're using this past summer. Did you put them on the draw marks? How'd you do that? Or?
Just one quick comment. Lynn and I have to run for a plane. As someone who has been involved in several Olympics, every quad they promised us we'd have this. They promised us we'd have this, and I know the disappointment of not getting it. And this is the first time I've been really excited that we're really getting there. So, thanks everybody.
Thanks, Tom.
So we'll stay here and keep going and answering questions to the extent we can. These guys, there's a snowstorm where they're headed, and they want to get there in time. Yeah.
How do you so hard on it? Yeah.
Yeah, so we had RTK GPS beacons on the ends of the line, but then on all the other marks around the course, we were just tracking them with mobile phones and just using the GPS in the phone. So it's not very accurate, but it was really just for like the entertainment purposes and the replay to see where they are. But you could also put RTK trackers on the marks, and then you could do things like, figure out when a boat's in the 3 boat length circle.
Yeah.
I've got a question about your production capability, because I think we've gotten past the technology, and Lynn and Tom are telling us it's fair. So I think we're there. How quickly could it take you to deliver these items to Yacht Club, and are we expecting production's delay if everybody in this room wants them for their fleet by Labor Day? Is that an issue?
You got to get your order in now. No. I'm also an ex-sales guy, so I love that kind of question. Clearly, Alec is going to be ramping up, and I'll hand him the microphone in a second. But there's nothing cosmic or untried and non-standard parts and things. These are all fairly straightforward technologies, but
easy for you to say. So our like in terms of production of the RTK puck, we're only going to be able to supply it this season for a few customers. So St. Francis, the J105 fleet in the Bay Area, and the New York Yacht Club, and a few other sort of launch customers, and then it'll be available to the broader public in the 2026 season.
And then one aspect of this to keep in the back of our minds is that the risks are logistical and the risks are production, but the risks are not technical. Because, remember, we did this 25 years ago for NASCAR. And we did it 12 years ago for the America's Cup and Sail GP, and it wasn't practical in terms of the size. But there's not a question of whether it works. I mean, it works perfectly for our sport. The question is getting it down to the size of a baseball so we can stick it on the backs of the boats.
Stan, you might comment. You once told me that you probably could do this with an Android phone if it got to that. I said, do you get that symbol?
Yeah, it's an interesting. Beau raises an interesting point. The system for Liveline, it had RTK GPS. It had two-way telemetry that couldn't use the cell system because the first thing that happens when a boat capsizes is everybody takes a picture, sends it, and the cell phone falls over. It had signaling for the sailors. It had a display, and everything the Liveline system had 12 years ago is in a phone today. And the smartphones today, the latest Androids, even have RTK chipsets. They're not capable of doing RTK because the antennas are cheap. But we proved that by getting a special Android phone with an external antenna, you could run RTK on a cell phone. You just can't do it with the cheap antennas they put inside the cell phones. So there's no question that this is practical. It's just a matter of getting it packaged up in a waterproof way, and so that it's practical to use in our events. It's also worth noting that it's unimaginable that people are actually going to do this with their phones, because I think we're too smart to take our phones and stick them in harm's way. So I think the puck is really the right answer.
Is this going to be rentable?
Rentable?
For a fleet of, let's say, fleet of 50.
Well, yes, if someone feels strongly that they can make a living renting these things out, sure. The installation and deinstallation will probably drive people slightly crazy, but yeah, it's and in the beginning, obviously, as Forrest was saying, St. Francis would try with our J22 fleet. It's a small fleet. We control everything. We're going to step forward one step at a time. Once this gets rolling in a couple of years, sure, I can imagine it would be, you could rent them out. Yeah.
Currently in the racing rules of sailing, are very specific instructions about what side is starting buoy, its port side, and people use various different types of buoys for starting, et cetera, et cetera. When you're calling boat OCS, are you following what the racing rules of sailing is saying where the start line is? And if so, how do you deal for a non-symmetrically buoy, a non-round buoy? How do you know it's actually OCS?
So I really wish Lynn was still here, but the way that we've dealt with, I don't have a super slick answer for you, but the way we've dealt with that so far is by defining the start line as being between two flags and having the transponders mounted on the flags. So that it's very exact. Stan, you want to?
Yeah, and that's exactly what we did for the America's Cup as well. The start line was defined by the SIs to be between the flags on the boat and the pin, and then that's where the antennas were, and that's what we measured to 2 centimeters.
Okay, so you can't rip a floaty buoy at this one?
Yeah, you can if it's got a flagstaff on the top. Yeah, and also, yeah, and the buoys in San Francisco, the buoys do this all the time.
Right. I was waiting for in San Francisco because you see, I'm just curious because there's very specific things, and yes, if you have a pin boat that is more or less stable, again, that works.
Yeah.
So what the two things that we've used for the pin are a pin boat and a mark set bot with a flag in the middle of it. But I think there's problems to solve in the future here, but just because we haven't done it already doesn't mean it's impossible.
Yeah.
So on that same line, what things should race organizers be thinking of? Like, there's additions to the race documents that be to be thinking about, but in terms of logistics and the workload of prepping, what can be?
Yeah, I'm a retired judge, so I'll take a shot. In the NOR and the SIs, you clearly need to spell it out in the NOR if it's a requirement. That's obvious, right? or if it's going to be provided by the host club. In the SIs, one of the things that some people have suggested, which is still being discussed by various international judges, is whether you should make this non-redressable. So in other words, don't let claims of redress stack up because you don't happen to agree with what's going on. I personally don't. I'm on the other side. I think it should be redressable, and as soon as people actually look at how accurate this is, they're going to stop asking for redress because it's startlingly accurate. And in the future, the amount of arguing and the time we spend in the room listening to people say they were or were not overlapped going into the zone, this thing can tell you that. You just replay the file and look at the two boats and say, nope, you weren't overlapped. And at some point, hopefully one of the vendors will actually give you that green, yellow, red, blue lights that just literally tell you whether you got an overlap or not. And we've all been around weather mark or a mark with people screaming and yelling, I'm overlapped, come on, that just disappears. So I think it actually will decrease the workload of judges at events once people realize they can't pull this stuff off. One of the things we didn't mention, which in this line also it interests me, we've gone to elaborate lengths with black flag and other penalty flags to make the racers behave. This thing will actually solve almost all of those problems because it can keep track of who's in the triangle. If you're in the time that you're not allowed in there, it can keep track of whether you cleared going around the end. I mean, all those problems just disappear. And the sailors will learn that almost immediately.
And the need for penalty flags also, because you don't have to do general recalls. If half the fleet's over, you just call half the fleet back. You end up not using penalty flags. So between an event at St. Francis and then the Resolute Cup and the IC37 Nationals, when we were using the full RTK system, it was like over 30 races in a row without a general recall and no penalty flags either. It changes the dynamic quite a bit.
Yeah, so I think we're underestimating the impact on the tacticians that this is going to have, where there's no place to hide anymore. And some of us in large fleets have jammed people up above us just to make sure we had a place to hide while we snuck across the line, and forced basically a general recall.
Yeah, I guess we're running out of time, but I had one interesting observation from when we first started using this in the America's Cup, is the nature of the protest room. That in the old days, we all have the experience of you dread going to the room because you end up in a somewhat concealed argument with your friends and colleagues, sort of doubting each other's truth. And it's unpleasant. And the interesting thing, even at the America's Cup level, is the boats go to the room, the first thing the umpires do, the judges do, is to replay the data. And then invariably what would happen is there'd be a long silence, and one team would put their hand up and they say, okay, we own that one. But what would have happened if we'd started to turn earlier? And so then you end up with a very collegial discussion about the rules, because there's no argument about what happened. And it's just an amazing change to the nature of the protest room when people aren't arguing about the facts, they're discussing the rules.
So I think we need to wrap it up. We're 5 minutes over, and we really appreciate the questions. It's very helpful, and thank you very much for attending.